Hello, dear viewers. Welcome into another Prokon gig. In this video, I'm going to show you how to design two-way slab in Prokon. Prokon you can use to design manually a safe and economical design. So you can see these working layout. We're going to select concrete and then slabs. Just okay. Then you need to fill in the data. You can see LX and LY. So we're going to see this from our slabs. I'm going to choose the most critical panel, which for me is 5.6 by 4.1 meter. I mean, the most critical basically means the largest panel. All right, so I'm going to pick this to be my most critical panel. So my LX, that is my shorter span, is 4.1 meters. My LY is 5.6 meters. Then we need to determine the slab depth. So you can see that the Prokon already draws a sketch. So I'm going to open my Epic pen. I think my license expired because I was using a free trial. So no problem, you can just use Microsoft Word instead. So don't worry. So this one, I think my free trial has expired. So we're going to choose another option. Because as I've suggested that in Prokon is more of manual because you are the one who determines the depth and all that manually. So I'm going to open my Microsoft Word. So to calculate the depth of the slab, because this is a two-way slab, to calculate the depth of the slab, so let me pick my pen from here. I'm going to pick up that pen. Sorry, I think my LX is 4.1. That is my shorter span of the slab, which is a rectangular slab. My LY is 5.6 meters. So from here we can determine the LY is to LX to determine whether this is a two-way or a one-way slab. So it's LY over LX, so don't worry about that. Over 4.1. If you do the calculations in our calculator, you can easily determine that the slab is a two-way slab because the answer is less than 2. So if you calculate, you find that the ratio is 1.37, which is less than 2. So it's a two-way slab, right? So the depth of a one-way slab is usually just Lx over 10 to determine the effective depth of a one-way slab. It's usually just Lx over 10. But for the effective depth of a two-way slab, like the one we are dealing with, it's usually equals to Lx over 30 plus Lx over 40 divided by 2. That will be the effective depth. So you find that the effective depth will be 4.1. That is, change that into millimeters. That is for 100 millimeters. So let me wrap this. It's not written properly. Okay. Let me erase this. Don't need, no longer need them. So Prokon is a very good software. It can save you. So I suggest my viewers, if you don't have Prokon, you should consider having it. You should download maybe a free trial and try it. So my effective level will be 4100 over 30 plus 4100 over 40, all that divided by 2, which if we do the calculations, it can be determined to be around 120. So that will be the thickness determination for a two-way slab. Already for a one-way slab, I've already shown you it's just Lx over 10. And remember, we design a slab based on the shorter span. That's why we're using Lx. So the answer is around 125. So let's do the calculation. So my answer is 120 millimeter. That is the effective depth. So considering we need a cover of around 25 or 20, so we can assume that the total depth will be 120 plus 30, which will be equals to 150 mm. Because now this one is the effective depth plus the cover. And that will considering the cover. So let's go back to our and fill this data. The slab length is 150 millimeters. Then we determined that our effective depth was 120. So I just say 120 mm or 120 mm. And we can just say that our dy should be around 130. So let's feed that in the data. So let dx be 130 and dy should be around 125, because I think my grade of steel is 450. My density of concrete is 24.5. My self weight factor is 1.4, and then E time just 1.2. So our load combination is combination 1. The dead load factor is 1.4 and the live load factor is 1.6. That is based on BS 8110 1997. So let's fill in the UDL. That is the um is it called the shell load, right? Not distributed. So for my dead load, let's say I have finishes of about 1.5, and I have sailing a load of about 0.5, that is a root of 2 kilonewton per meter square, and a live load of 4. This is also based on the code because the house I'm designing is a school, so the code determines it to be around 4 or 3. So, and you can see the total UDL down there is already calculated. So let's assume we have a line load, although in the design we did not have a line load, but let's just do it for the sake. So let's say we have a partition wall of about 3.4 kilonewton per meter, then its location in X around the center, then Y1. So you can see now the sketch of our partition wall. So in the design there was no partition wall, but here we're just assuming for the sake that we have a partition wall in that critical slab. So we just click design, and you can see now our moments, our deflection. So this one is a short-term deflection. So I want to erase, I'm just going to go to backspace. So we need to determine the ultimate deflection for this critical slab, so that we can determine now we can determine whether the depth that we assumed has passed. So this is why I say that Prokon is more of manual, and I have a notion that manual design is more accurate. So me, I love doing manual. So we're going to do what we call deflection check. So ultimate deflection, that is UD, should be equals to Ly, that is the longer length, over 500, and Ly was 5600 millimeters. So let me write this properly. Divided by 500 should be about 11.2 millimeters. That is ultimate deflection. So we need to compare this ultimate deflection with short-term deflection and also long-term deflection to determine if it passes in both. It has to pass in both short-term and long-term, so that the depth will be now okay. So our ultimate deflection is about 11.2 millimeters, mm. So 11.2 mm. All right. So you can see this is a short-term deflection, and you can see the ultimate short-term deflection is 2.8. The one in the center is short-term deflection. So load case 1. Let's go to long-term deflection. So long-term deflection is 12 millimeters. Load case 1. This is based on ACI 3.8. So this is a good thing about Prokon, because even it's designed based on the on both BS and ACI code. So because our 11.2 mm is less than our long-term deflection, the deflection check has failed. So a depth of 150 mm is not okay. So I'm going to rub with my pen. So 150 millimeters depth, not okay. All right, so we need to increase the depth to around 175 mm and see now if our deflection is passing. So you can see the moments, deflection. So long-term deflection is now 4.80. Now that is the ultimate, which is less now, which is less than the ultimate deflection. So the shorter deflection is also 1.8, which is less than 11.2 mm. So depth 175 mm is okay now. .5 is less than ultimate. So now the deflection check has passed. So a depth of 175 mm is okay. So we're going to go to reinforcement. You can see the reinforcement area, and you can see the maximum values, the calculation sheet, the bearing scale. You can see we need T10, 70 T10 at a depth of 50. Then T10. Remember in BS we just use T, not Y, right? So that one, when you are detailing, you should check that. So let's generate. So we're going to go to calc sheet. We need to print the calculation. So I can go to output settings and select what I will need to print, what I need to print, because I cannot print everything. So I'll print input, everything, reinforcement, all, then deflection, and then uncheck text output, because then we can edit in our deflection. So we can add text. So we can send this just to CalcPad so that you can be able to edit the job number, the title, and everything. So I will just load default, or you can just edit. All right. So so do you have deflection? Can't see my deflection. So we are going to go to and go back to our calc sheet and then check it, because maybe it's not checked. That's why I can't find it here. because we need to indicate that the depth passed in deflection check. That one we can just type manually. Because without that, how can you prove that your slab has passed? So, because you need to defend your design. So without that in your calculation, you will have to explain how decided that particular slab passed in deflection. So you just need to use the calculation for this one slab. And remember here we included a partition wall, so which was not initially the original design. So don't worry that there's that difference in results, because I just this one is I'm using as an example. Remember this is a critical panel, and I've added a partition wall, so it will be very critical. So that's why the only depth that could pass is 1 centimeter. So we need to include our deflection. So I need to check deflection. So I need to check deflection. Yeah, then okay. So I'm going to new. I need to start a new and then send to calcpad. Then let's see. You can see all the input. Load my default, and then change the date, the current date. Then okay. So now we can see our deflection results. Then we can, from there, we can just edit. So thanks. If you like this video,